Okay, so for for subnet addressing, for the first question, okay, so consider the router 0/24, and as you can see here, for A there is 56 hosts, in B there's 18, and in C there's 21. Now, is the address space public or private? So what you have to know is that private addresses, there's only three IP addresses that are private. There is 10. These are the private IP addresses that exist currently. So these three are private. Anything else is public. So 44 or 50 or 210 dot whatever is public, but 10.x.x.x or 172.16 to 172.31 is private, and 192.168 is private. So since the IP address above here is 10.176.72.0, it is a private address space. And for how many hosts there can be in an address space, it is 254. And to get that is the way to get that is that there is it has given the subnet mask in the CIDR format, which is 24. And to find out the total number of hosts, all that's needed is 32, which is a total number of bits, because in every subnet bit there is 8 ones, so there should be 8 subnet bits in each block, and there are 24 that is taken. So it'll be so you see this is the amount of available host bits, right? So to find the total number of hosts, it is just 32 minus 24, which will give you 6 total subnet masks. And then from there, it is 2 to the power of 6 minus 2. So that would be, calculator, a total of 64 or 62. So 2 plus 6. Yeah, that would be 62 hosts available for each subnet. But currently there are only 24. Now, what is the subnet address of subnet A? So where I get stuck at is basically when you're trying to find out the network address for a question like this, it is not alphabetical. So you will not start from A to B then C. How you're supposed to calculate it is based off the amount of hosts in each subnet. So instead of doing it as 56, 18, and 21, which is chronological order via the alphabet, you have to do it from largest host quantity to the lowest host quantity. So as I've said before, it's instead of A, B, and C, it's A, C, B. Because you're going from the largest to the smallest. And how to calculate this is that you have to find out the host bit. So since there are 24 bits that are taken and 8 that is left, from those 8 we will have to just divide them into smaller subnets. What I mean is that in here, so here there are 8 zeros. From there we can make them smaller, we cannot make them bigger. So what will happen is that you'll simply have to calculate it. You have to, instead of finding out the subnet bits, you have to find the host bits. So what I have done is that I have simply taken these 8. I've taken these 8, and then I have then put out the bits, the bit capacity or the bit placement, and then from there I have worked slowly, which it sure will take a bit more time, but it's just easier. And then from here, I need, for subnet A, I need something that can fit 56 hosts. And I have to do it while taking the least amount of space possible. So what I mean by that is that I cannot have 56 hosts inside a subnet that is meant for 128. It will be simply inefficient and it will take unnecessary space. So I will do 1 for 128 and 1 for 64. The reason why is that, again, we're not looking for the subnet bits. We're looking for the host bits. So what I have done is that I will do 32 plus 16 plus 8 plus 4 plus 2 plus 1, and that will give me 63 hosts, which is 6 host bits, because then these are now 0, which is able to fit 56 hosts. So now that would mean I will just now that means this in the CIDR format is 26. And now if I do the math again, 32 minus 26 equals to 6, and then that's just to find the total number of subnet masks, and then I do 2 to the power of 6 minus 2 to find the hosts, which will give me a total of 62 hosts. So the starting IP address, and since you're going to start from largest to smallest, the first IP address for A is going to be 10.176.72.0/26, not 24. Because 24 means 254 hosts when I only need 56. So to accommodate, I have gone down to 64 hosts. And then of course the broadcast address is just the second to last IP address in this subnet. So it will be 10.176.72.1.63. because 62 hosts, and then 62 plus 1 is the broadcast, and then 63 plus 1 is the last IP address on that subnet before for the next subnet mask. The starting address is of course the first IP address, the 10.176.72.1. The end is the last IP address, so it would be 10.176.72.63, because now at 64 it's the start of the next subnet address or the next subnet mask. What the? Oh, sorry. This question is a bit confusing because I keep thinking it's the last IP address when it's meant to be the last host IP address, so it's 62. Now, for B, because B is the last one we have to work out, because B has the smallest amount of hosts needed, we will have to work that out again. So, since we've used 26, which means out of the 254 hosts, we have used 62. That would leave us with 192 more hosts that we can use. So if we go back to the Sidr 26, which means the subnet mask is /26, or for those who don't understand, it is 255.255.255.192. We have to try to use less because we only need 32. We do not need much. So I will just simply work it out again. So if I just that will be so it will be 128, 64, 32, 16, 8, 4, 2, 1. So I do not need 128, I do not need 64, and 32 for the host, sorry, for the subnet mask, because all I need is 16 plus 8 plus 4 plus 2 plus 1. That will give me a total of 31 hosts to use, which is more than enough. That would mean this is now my new subnet mask for B and C. So that means the CIDR would be 27 instead of 26, because that means the total number of hosts that I can use is 32 minus 27 is the amount of subnets I can host. It's 5 subnets, right? So 32 minus 27, which equals to 5 subnets, and then I use the formula to find the hosts. So it's 2 to the power of 5 minus 2. So that would mean I would have 30 hosts to use, which is enough because 16 would not be enough to accommodate for 18, neither for 21. So what I have done is that now I have found the subnet masks for B and C. But then, as we can see here again, as I've mentioned before, B is the subnet, address. Oh, sorry, B is the subnet group that has the least amount of hosts. That means we have to work on that last, if I recall correctly. Okay, just a brief intermission. So the subnet address for B should be, oh sorry, I didn't explain why. So if, so I'm not, so since B is the subnet, so since B's address space is has the least amount of hosts, I will work on C first. And since C has 21, which fits into 30, it will use the same subnet mask. So what that means is that the IP address for C would be 10.176.72.64, right? I will keep that in another space, right? So after 64, there's going to be 32 available spaces. So I just add 32, which will give me 96. And that is now going to be the starting address for network B. And as for why it's in host order, not alphabetical, I do not know. Simply put, I do not know. So the reason why it's 96, the reason why it's 96 again is because from my understanding of the questions, it's from largest to smallest. So I've worked on C already, which has the network address of 10.176. Dot 64, because that has priority because it has more hosts, and then B is last because it has the least. So, and they all share the same subnet mask because they all have less than 32 hosts. So 10.176.72.96/27, and then of course the broadcast would be 96 plus 32, so it would be 10.176.72.127. Sorry, plus 31, because it's the amount of hosts plus 1 for the broadcast, and then it's the amount of hosts plus 2 for the next subnet mask, for the next subnet address. And then the starting address, which is the first IP address given, which is 97. And then the ending, which means it's the last IP address to, which is not the broadcast, so it's 96 plus 30, so 10.176.72.126. And since we've already figured out the subnet address of subnet C, it's 10.176.72.64. I'm sorry, I forgot the sitter, /27. And the broadcast is 10.176.72.95. The starting, which is the first address, which is 10.172.76, sorry, .72.965. And then the last IP address being able to be given is 10.176.72.694, and that's it.